Okay, so this will be a little brief video talking about how to use the unit circle. Now, it's not going to be super in-depth, just kind of, once you've seen it and kind of had some basics given, this will be maybe just a refresher or, a quick idea of what it does for us. So basically the unit circle, big thing obviously with trigonometry, it's going to help you find the sine, the cosine, and also you can get the tangent just by knowing a bunch of coordinates of these special angles around the circle. Okay, so basically what it boils down to, it looks very overwhelming and intimidating with a million blank spots and all that stuff. Um, but what I want to kind of focus on is if you can just own the first quadrant, okay, like if you really get these patterns down and you just really focus in on that first quadrant, you'll be able to see then how they can be applied anywhere. Okay, so basically the idea again, unit circle is just a circle with centered at the origin. Okay, so right here, just think like when you plot points, like that's 0, 0, and the radius of the circle is 1. Okay, and that's what makes everything work nicely. So coordinates out here, just in, thinking about if you plot a point, if and just to visualize it, if the origin is right there, the 1 unit to the right, that's right here. The coordinates are just 1, 0. Okay, if you were to go up here, um, that is 1 unit above the origin, so 0, 1. Okay, likewise over here, negative 1, 0. And then down on the bottom is going to be your 1 unit, so 0, negative 1. And those angles in degrees are 0. Okay, so we haven't gone anywhere yet. Straight up is a 90-degree angle. Okay, to the left is a 180-degree angle. And then on the bottom is a 270-degree angle. Okay, because again, just as a refresher, you're always imagining when you measure an angle, it always starts out from the positive x-axis, and then it goes this way for positive angles. Okay, so that's why you get 90 degrees when you're going straight up. So those are the coordinates of those borderline angles, and then there are 3 special angles that you just need to know. Okay, and they are the 30, 45, and 60, and those come from 2 special right triangles. You may remember the 30, 60, 90 triangle, 45, 45, 90 triangle. So basically those are going to be the angles that you see here. 30, 45, and 60. Okay, and we'll talk about the other quadrants in a little bit. Okay, the radian value, there is a conversion factor. If you remember, you can just multiply by pi over 180. I'm not going to spend a lot of time on this, but I'll just put these up here. This one would be pi over 6, or 180 over 6 is 30. Pi over 4, because 180 over 4 is 45. And then pi over 3 is 60 degrees, because 180 over 3 is 60. And again, that's all based on 180 degrees being pi radian. So again, that's something you can get some more information on other places. Okay, so here's the deal. Okay, with these, if you set up the coordinates, there's a pattern here, a very simple counting pattern that I really, really enjoy. So let's thinking about these y coordinates. Okay, and then we'll talk about what those values are. So the y values are going to increase, right? As you move this way, as you go up, right? Think about plotting a point. A y coordinate is going to be higher. Okay. So actually, one other thing before we do that, every single one of these is going to have a 2 in the denominator. Okay, that's one big pattern right there. Okay, all the way around the circle. Okay, except for the ones on the x or y axis. So even when you're over in quadrant 2, no matter what, they're all something over 2. Same thing in quadrant 3 and 4. Now here's the easiest pattern to remember. Okay, if you start out when you're at 0 degrees, right here, the y coordinate is 0. As you move up, it just goes up by consecutive numbers. It goes up to 1, then it goes up to the square root of 2, and then the square root of 3. Okay, now you could think of there being a 1, or a square root, I'm sorry, over the 1 if you wanted to, because the square root of 1 is just 1. So we usually don't write that. But notice that pattern does work if we go square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. Once you get up to here, the next number in the pattern would be the square root of 4 over 2, okay, which really is, the square root of 4 is 2. So 2 over 2 does equal just 1. So if you really want to follow the full pattern, it does apply. Okay, and even better news is the x values, okay, those x coordinates follow something very similar, starting with 0 here. That'll be 1 over 2, then root 2 over 2, then root 3 over 2. So let's fill those all in. Okay, 1 over 2, root 2 over 2, and root 3 over 2. Okay, and I'll just show one other quadrant, but there's some other ways around this as well. But as far as in quadrant 2, again, think about your y is 0 over here. So as you work your way up, you're getting higher y values. So the same pattern applies over there. Okay, and with x values, if x is 0 up here at 90 degrees, as you go to the left, the x's are getting negative. They're getting more negative. So negative 1, negative root 2, negative root 3. Okay, and you can do a similar pattern in quadrants 3 and 4. Just the y's would be negative down there, that kind of thing. But here's what we did. Okay, and I'm going to try and emphasize this. When you visualize a right triangle in quadrant 1, let's say that one right there. Okay, so it's a nice right triangle. Okay, with a 30-degree angle in there. Right, this angle would be 30 degrees right here. Okay, the key to the unit circle is that the x-axis always acts as the adjacent side, okay, to this angle, while the y value, the vertical side, is the opposite, and then the diagonal side, of course, is going to be the hypotenuse of a right triangle. Okay, here's the magic, right? The hypotenuse, if you just visualize, the hypotenuse is actually from the center of the circle to the edge of the circle. It is just the radius of the circle, which is just set to be 1. Okay, because that's what the unit circle is. It has 1 unit radius. That's what the unit stands for. So what we really did was we just found the sine and cosine of the angle, because the x value, okay, for the adjacent side is that value right there. It's root 3 over 2. And for this specific angle, the opposite side is 1/2. And the reason that helps us is because when the hypotenuse is 1, we know that, for example, let me just get a clean page here. Let's say they ask you, let me just draw that first one real quick. When they ask you for the cosine of 30, for example, okay, let me just redraw that triangle. We had this here, there's 30 degrees. The hypotenuse is locked in as 1. We said that's 1/2, and that's root 3 over 2, right? Those were the coordinates of this point. The x was root 3 over 2. The y was 1/2, right, on the unit circle. So when they ask you, for example, like, what's the cosine of 30 degrees? Okay, and they want an exact value. They don't want, throwing this in a calculator and getting a decimal, because, I mean, these type of questions could actually be required without a calculator. So what you're going to do is think about, all right, cosine. Cosine is adjacent over hypotenuse, right? Go back to SOHCAHTOA stuff. Okay, the adjacent side is right here. It's always the horizontal, the x value side. So the adjacent is root 3 over 2. And again, the beauty of the unit circle is that the hypotenuse is always 1. So something divided by 1 is just whatever the numerator is. Okay, so that's what makes the x coordinate always be the cosine of the angle. Okay, and similarly, the y coordinate, since it is the opposite length, okay, right, this y coordinate here is always the opposite length. So the y coordinate will always be the sine of the angle. Okay, so just by knowing those patterns, you now know, let me go back a page, we know now the sine and cosine of all of these angles. Okay, the x coordinate is the cosine of the angle, and the y coordinate is the sine of the angle. Okay, and remember, the coordinates are found just by doing the simple counting, the 1, 2, 3. Okay, so let's use it. Let's try and answer some questions. There's other methods out there. If you don't really like the counting, there's a way, if you search for like the left-hand trick or whatever, it's kind of a cool way. Personally, I kind of like this way, and I always suggest to my students just to draw out that first quadrant. As soon as you get your test, I mean, let's see how fast we can do that. You get your test, okay, there's 3 angles in here, 30, 45, 60. Okay, we're just doing the, again, starting at 0 degrees. I'm going up in the y direction, root 1 over 2, root 2 over 2, root 3 over 2. 90 degrees, I know the coordinates are 0, 1, so the x's are going to increase as I go to the right. Okay, that's it. Boom. Okay, the other thing it can do for you, is knowing the tangents. Okay, those are a little bit trickier. So the tangent of an angle is always the opposite over the adjacent. Okay, so the way that we have these set up again, let me just draw one of the triangles again. Again, the opposite is always the y value, and the adjacent is always the x value. Okay, so tangent can just be thought of as the y value over the x value. So you don't really need to memorize new values. You just need to know the x and y and then divide them. So let me just give you a couple of these values here. For 45 degrees, the tangent of 45, that's the easiest one on there because notice how the x and y are the same thing. So something divided by itself is just 1. Okay, the other two now, I'll do one of them for you. If you needed, let's say we needed the tangent of 60. Okay, and tangent of 60, so it's 60 degrees up here, right? So its y coordinate is root 3 over 2. Its x coordinate is 1/2. So we want to just kind of simplify a fraction divided by a fraction. So just to see what would happen, we're going to take the numerator times the reciprocal because we're dividing by a fraction. And what ends up happening a lot of times, something will cancel out like those 2's here. So the tangent of 60 is just the square root of 3. Okay, and you could do something similar. I'm not going to show the dividing by the reciprocal or multiply by the reciprocal, but this one actually simplifies. You'd have a square root in the bottom when you do the division, and you need to rationalize that. So that's another little topic I'm not going to do right this second, but it ends up being root 3 over 3. Okay, so really those three values show up all the way around the unit circle for tangents, and there is kind of a way to remember them. So again, the 45s you just need to know is 1. So if you're ever in the middle of a quadrant, for example, this angle right here, that's a 45 reference angle. So its tangent would be, in this case, it would just be -1 though, because the x coordinate's negative. Okay, but to remember the two, tangent is y over x, right? So it can narrow it down to root 3 or root 3 over 3. Which one of those two numbers is bigger? Okay, well, root 3 is bigger because the other one here is root 3 divided by 3, which makes it smaller. So I just kind of always remember that one goes with the smaller angle. You know, the root 3 over 3 goes with a 30-degree angle, while the root 3 goes with a larger 60-degree angle. Okay, so either way, or just know the coordinates and go through this little process where you do the division. Okay, but let's do it. Let's do a couple problems. Some specific problems. This was from a review that I gave in class. Okay, so number 7, the sine of 270. So let's think about on the unit circle, 270 degrees, right? So again, I know it goes 0, 90, 180, 270. Okay, all right, so 270 is straight down. Okay, the point on the terminal side, 270 is right there. This is 270 degrees. So anytime they're asking for the sine or cosine, they're really just asking for the x or y coordinate. Okay, so the coordinate right there, if you're just down 1 unit, remember this is the origin, so down 1 unit means the y needs to be -1. Okay, so the sine of 270 is the y coordinate there. That's it. Okay. All right, so that one was a little borderline value. Number 8, tangent for 30. Okay, I'm going to draw a little quadrant. I know I'm in the first quadrant. I know 30 is the lowest angle. Okay, because then I know I have 45 and I have 60 in there. So I'm thinking, all right, coordinates of 30. I know using our little counting trick, the y coordinate is 1/2. The x coordinate's root 3 over 2. Okay, and now we need tangent, right? So I could just simply do the y divided by the x. Okay, and then, which would involve multiplying by a reciprocal. Okay, or I'm remembering again, I'm kind of narrowing it down to, is it either root 3 or is it root 3 over 3? Right, I know it's not 1 because the 45 would have a tangent of 1. So I'm thinking this is the lower of the two angles, so the opposite side is kind of the smaller side, so it's going to be root 3 over 3. Okay, if that way doesn't stick, again, just do y over x, multiply by the reciprocal, and simplify. Okay, a couple others in radians. So real quick, how to convert from radians, we're just going to replace pi with 180 and simplify. What I kind of do is think about, like, let's say you didn't have a calculator, you couldn't use one. 180 over 6 I know is 30, so I have 7 30s. So I know it's 210 degrees. Okay, now we need the cosine of that though. Okay, sometimes students kind of stop and they'll tell me the final answer is 210. That's not true. We still need the cosine of 210. So here's how we apply that to the unit circle. We're going to think about what quadrant 210 is in. Okay? Okay? Or if you're comfortable with radians, don't even worry about converting. Just leave it in radians. But anyways, 210, you're always thinking about making the x-axis be the adjacent side. So I want to know how far past the x-axis is 210. So I know I'm past 180 by 30 degrees. Okay, that angle right there would be your 210. So we need those coordinates of that point right there. Okay, remember 30 is the smallest one. Right, 30 is the first one down. So its y value, if we're counting, if that is negative 1, 0, if I go down to the first one, the y value goes to negative 1/2. Oops, I wrote that negative sign in the wrong spot. So the other one, it always gets paired up with root 3 over 2. But in this quadrant, we're down in the third quadrant, the x's are negative as well. Okay, and again, if it helps, think about there's 45 past 180, there's 60 past 180. We are at the first one down. Okay, so now I just need to think about, again, what were they asking me about? Cosine, cosine's an x coordinate, boom, negative root 3 over 2. That's it. Okay, let's do one more here. 2 pi over 3, again, if you were to convert that into degrees, again, I know pi over 3 is 60, so I have two 60s. So it should end up converting to 120. Okay, so let's think about where 120 is. Okay, how far from the x-axis? This is that whole idea of finding a reference angle. Right, well, if the x-axis is 180, I know I'm 60 degrees short of that. Okay, because there's my actual angle of 120. But I'm using the 60 as a reference angle because, again, there's a 30-degree angle in quadrant 2, a 45, and then the one we're on is the tallest one, the 60-degree angle. So when you go and get the coordinates for that, okay, let me just go back here. Okay, just to visualize it, right, this is 30 degrees short of 180, so that one would be the 150. That's 45 short. It's always these same three reference angles. If that's 60 short, there would be your 120 right there. Okay, so we see again the y coordinates just go from 0 to 1/2 to root 2 over 2. Root 3 over 2 is the one we're looking at. Where are we at down here? Okay, and I needed sine, so I needed the y coordinate. So positive root 3 over 2 is our answer there. Okay, the other thing you can do is work backwards a little bit with solving an equation. This one, same thing, there's still unit circle values. They just want you to find the angle measure. Okay, between 0 and 360, so within one circle around. So let's think about, for number 11, the sine of what angle is negative root 3 over 2? Okay, I know sine deals with y values. Okay, y values are negative in the quadrants below the x-axis, so in quadrants 3 and 4. So I need to think about, is it that first one? Is it 45 away or is it 60 away? Okay, and then I'll do the same thing in quadrant 4. Which one of the three would have a y coordinate of negative root 3? So again, I know here the y coordinate is 0. There it's negative 1 over 2. There it's negative root 2. So it's this one down here where the y coordinate would be negative root 3 over 2. So it's a 60-degree reference angle. Okay, same thing in quadrant 4. It's 60 degrees past, or 60 degrees short of 360 if you want to think of it that way. Okay, those are the two angles with y coordinates of negative root 3 over 2. So if we just think about 180 adding 60 more, that angle would be 240. Okay, and in quadrant 4, we are 60 degrees short of a full circle. So 360 minus 60 would be 300 degrees. Okay, so those are your two answers. 240 degrees, 300 degrees. Okay, and make sure a lot of these seem to get two answers. Not all of them, like I'm looking at this next one. It's not going to get two answers. But with number 12, cosine of theta equals negative 1. Okay, cosine is basically like an x value. So on your unit circle, which one has an x coordinate of negative 1? that's the one over here, right? Because that's the one that's just one unit to the left of the origin. So there's only one angle there that has a cosine of -1. Okay, so hopefully that helps. Come up with some patterns. You know, it just sometimes takes a little while to click, but check out other videos. This is exactly how I've done it. I just found this method a couple years ago, and I think it's best. Just doing the counting trick, and then thinking about quadrants and where x is positive, where y is positive, all that good stuff. All right, hope it helped you.